So hello everyone. Today I would like to talk about the habitat mapping because I did choose the habitat mapping topics in the oceans mapping project with my instructor Dr. Ian Josh. So today I just make a very brief overview about that. So about the contents, the first one I will talk a little about some introductions and get a brief overview about the reasons habitat mapping research. And finally, I will get some conclusions about that. About the introductions with the objective. So as you know, the multi-beam sonar echo sounders play a very important role in building a habitat mapping, which supports a lot for the marine biologists to observe the marine habitats. And in these sections, I would like to focus more on the first one, summarize some habitat mapping research. The second one, just update some sonar techniques in the marine habitat mapping. And finally, present some example of the data visualization as well as some results from these research. And about the history of sonar, so in the earliest stage, the scientists they just measure the seafloor depth by a very basic techniques by the rock. But so you know that with this technique it create a lot of errors because of the bendings of the rock and the ship moment. But in the 1992, the echo shoutings were used to record the sea floor informations. And in the next day, 1950, it's a very new era in producing a large-scale seabed map. And we have our first publications about the multi-beam echo sounder in the 1960s, and until 1980, with the develop of the computer power, we have a lot of digital projects in the mapping seabeds, and it's the very brief history about sonar survey. And about the habitat mapping research, the first one I want to talk a little about the a paper research from Nicola and his colleagues about using a multi methods approach for Benthic habitat mapping of shallow coastal areas with high resolution multi-beam data. So in this research, he and his colleagues the first one used the multi-beam echo sounder to check the bathymetry and backscatter data line in here. So our Dr. Ian Church, he talked a lot about this kind of methods in the class and the data. So I will skip this one and go to the next methods. The next one is the remotely operated vehicle imageries. So how it works? So this one is just a machine to take the image under the water, and with this one you can control the machines when you on the boat. And this machine is equipped with the camera, echo sounder, and manipulator, and you can just control it and can see what happens under the water on the seabed. And this picture is about the photograph by a diver. So this one is have a trans diver. He is taking a photo on the seabed like this. Yeah, just make a diving survey by persons, by human. And with this image it represents about the sediment sample. So in here you also have you also have it's called a box corner. This one is you can see it have a small solver here with the glow and opens mechanism on the left side. So when you push it into the sea and trigger the system, this one will be open and swing down, slide across the bottom to take the sample, the sediment sample, and trapping accused of upper small seafloor sediment. Yes, and yeah, and even is also have the seawater inside. And when the machine take the sample, you can control it when you're in a boat, and yeah, just take the sediment sample easily. And in here with the figure 4, they have the backscatter data and the image here, and make a comparisons about the features inside. And you can see here is have the sands and gravel here. Yes, compared with the backscatter data they have before, and finally got the map like this. And with the map you can see it presents the shape on the seabed, like grass or flats or something like this, and it also have the material in this kind of areas, like here in the with the red color is have a sloping with the medium sand or scratch shape with the sands and gravels, for example. Yeah, and with the habitats mapping, you can see you can know the informations about the shape and the material on a particular areas on the seabed. Yeah, and the second one is the papers from some about the comparisons of the methods for the integrating biological and physical data for the marine habitats mapping and classifications. So let I talk a little about what is the biological data and physical data. So it have two kind of sample here. The first one is the biotics, and the second one is abiotics. Biotics means the living things. It's like and in this paper is will be the animal, the very animals in like this in the right side. And abiotics is mean the non-living things. And in here is in this paper is talk about the soil. Yeah, the kind of soil, gravel, sand, mud, something like this. In this paper talk a lot about the macrofauna. So what is this? So macrofauna is describe incredible range of life form. So to easily understand that, you can know that it's just a very very small animal live on the seabed surface. Yes, and this one is the kind of the animal mentions in this paper. And with the methods, they also use the side scan sonar data, bathymetries, data, and the bottom sample. It's like the bottom sample is the sediment sample and the macrofauna assemblage. And how to take it? I just mentioned about this one. Yeah, so this one is the things they take the bottom sample. And in this paper, they also use a method is called the cluster analyzing, a kind of the statistics methods for this research, and mapping by objects and classifications based on the norm versions, yeah, about the catalogs of habitats. And yeah, this one is the pictures about the stations, their study areas in Greenwich Bay. Yes. Yeah, for cluster analyzing. So this one is the kind of the statistics methods. And in here, you can see here they have a lot of sample. The number here is the sample they have, and you can picture in your mind that they have a lot of data and they have to deal with that. And statistics methods is a very good methods to do that. So with the cluster, they just put all of the data and analyze it by cluster methods. And in here, with the cluster methods, they give you four group like this. Yes, they just based on the statistics technique methods to divide the data into four group like this. Yes, 1, 2, 3, 4, and with the group you have, yeah, this number of the data is for the group, the first group. This one is the second, the third, and yes, the final group. And in here, the table will present very detailed information in each group. With the group one, you have the kind of the biotics information. Here is Spiocatopterus. It's a kind of the name of the animal or live on the seabed. Yeah, so the table just give you very detailed information about the group here. And with the map, so here they just combine the backscatter data, the depth, the bathymeters data, the percentage of the material sand, yeah, and get the kind of the map of the like the surface geology components, surf glass. It's like you can know where is the moss, where is the sand, and combine with the biotics components, and you get the final habitat map like this. And in here is like it's also like the final result of the reviewers research I have mentioned before. In here is you have the biotics, and Paliscara is the name, also the name of a kind of the animal live on the muddy sand, and you based on the color you can see where they live, and the area they live is have the mud and sands. Yes, here. And yes, Spiocatopterus also is the name of the kind of the animal live on the seabed surface. Yeah, and also reason about the kind of the material in here. So with the map, you can know the spatial environments of the biotic community. Yeah, biota is the spatial environments of the biotic community. Is the area, the living areas of the animal. Yeah, and in this research, they also provide a very detailed table about the glass they this devise in this presents on the map, on the habitats map, and you can know a very detailed information about the biotics component on its glass like this. And yeah, just read the table compiled with the map, and these the parameters here is just the statistics parameter. Yeah, and the index is just kind like with the statistics method is have an acceptable index, and this the database in this research just meet the acceptable standard. So the meaning of the number he does. Yeah, and the next research is about a habitat mapping use a tool for conversations and sustainable use for the marine resources. And in here they use a particular program. It's called Marino program. Is from Norway. Yeah, here they also use the high resolution data, bathymetries, and backscatter data. Use the video inspections. Yeah, like this. Use a very certificates machine to take to record the video on the seabed surface like this. Yes, classify the marine habitat. It's different group will make a map, and in this research they use marino mapping programs like this. And yeah, this one is the different thing in this process, because this one is the kind of a picture present about the marino program, and you can see here it's very amazing, right? Because in this program they just integrate everything in this program. So with the other resource, they have to use the other software to map the habitat mapping. Yes, and make classifications on the arches, or analyze the images data in a particular software. But in here, Marino program, they have everything's here. They have the bathymetry, even they have the gap goal information. Here is within the elevations, the depth of the seabed. Yeah, and about the biotics informations also here. Look very amazing. So if I have a chance for using that, I will try it. Yeah, and the process is just the same with the reverse research. Just use the depth, the bathymeters data, backscatter data, just classify the data into different groups and make the map like this. And in this software, they also present for us the very good image about the seabed survey, and you can know what's happened there. Yeah, and something live on there is very amazing. Yeah, in the process, yeah, just collect the data, identify the fauna group, like I just mentioned before, make a difference group, and make predictions about the biotop distributions, the living areas of the animal, yeah, and have a final map like this. Yeah, in the final map is, yeah, just the same, right? The same with the reviews. So actually, in the different research, different paper, different publications, they have a different process for the data, but basically, to me, the process basically just the same. You just collect the data, analyze it, and put it on the map. And the difference is which uh, the difference here is just locations, the methods you use, and yes, it's make the difference in these research. The conclusions, yeah. So after that, I learned a lot about their technique, also about their result, how to work with the bathymetries data, yeah, how to compile the high resolutions bathymetry and backscatter data, how the operators vehicle imagery machine work on the seabeds, and how to take the sediment samples from diving survey, and yes, also the using the statistics methods to do a very good habitat map, and with the ground trusting of the habitat map. In here, the image, the dive from the diving survey, dive observation. This one is the purpose for the diving survey is to verify the habitat mapping, verify the accurate habitat mapping, just for verifications that you build a map with the bathymetries and backscatter data is correct or not. And yes, the habitat map is strongly support the marine spatial planning. Yes, support a lot for the marine biologists for their research and management. Yeah, and thank you so much for your watching, and I hope to get your feedback about my presentations, also about my informations I get here. Something maybe something is still not correct or not really good. So yeah, hope to get your feedback a lot. Yeah, thank you so much.